Okay, Chapter 2 of the Principles of Operation publication for the IBM 370. Let me crank through these two paragraphs really quickly because then we're going to look at a diagram. They say logically, System 370 consists of main storage, one or more central processing units, operator facilities, channel sets, channels, and I/O devices. I/O devices are attached to channels through control units. The physical identity of these functions may vary among implementations called modules. The figure, logical structure, depicts the logical structure for a single CPU system and for a two CPU multiprocessing system. Specific processors may differ in their internal characteristics, the installed facilities, the number and types of channels, the size of main storage, and the representation of the operator facilities. The difference in internal characteristics are apparent to the observer only as differences in machine performance. Okay, so here's our single CPU, and then here's a multi-processing 2 CPU diagram. So main storage, both of them, that's where we start. Okay, I'll just focus on the single CPU to start with. We have 2 channels, part of a channel set, and we see the lines come down from each channel there. They say a system viewed without regard to its I/O devices is referred to as a configuration. Interesting use of that word. Well, they go on to say all of the physical equipment, whether in the configuration or not, is referred to as the installation. Okay, so physical installation, got it. Model-dependent reconfiguration controls may be provided to change the amount of main storage and the number of CPUs, but also channels and channel sets in the configuration. In some instances, the reconfiguration controls may be used to partition a single configuration into multiple configurations. Each of the configurations are reconfigured, has the same structure, that is, main storage, one or more CPUs and channels. Each configuration is isolated in that the main storage in one configuration is not directly addressable by the CPUs and channels in another configuration. It is, however, possible for one configuration to communicate with another by means of shared I/O devices, the direct control facility, or a channel-to-channel adapter. At any one time, the storage, CPUs, channel sets, and channels connected together in a system are referred to as being in the configuration. Channel sets and the associated channels are considered to be a particular configuration as long as they are connected to main storage, independent of whether or not the channel set is connected to a CPU. Each CPU, channel set, channel, and main storage location can be in only one configuration at a time. Okay, so let's read about main storage, which is directly addressable, provides for high-speed processing of data by the CPUs and channels. Both data and programs must be loaded into main storage from input devices before they can be processed. The amount of main storage available in the system depends on the model, and depending on the model, the amount in the configuration may be under control of model-dependent configuration controls. The storage is available in multiples of 2K byte blocks when either test block or the storage key 4K byte block facility is installed. Storage is available in multiples of 4K byte blocks. At any instant in time, all CPUs and all channels in the configuration have access to the same blocks of storage and refer to a particular block of main storage locations by using the same absolute address. Okay, so I'm going to skip the CPU section. There's nothing particularly enlightening, interesting, or insightful about that section, but I do like this PSW section, so I'll read from here. The program status word includes the instruction address, condition code, and other information used to control instruction sequencing and to determine the state of the CPU. The active or controlling PSW is called the current PSW. It governs the program currently being executed. The CPU has an interruption capability which permits the CPU to switch rapidly to another program in response to exceptional conditions and external stimuli. When an interruption occurs, the CPU places the current PSW in an assigned storage location called the old PSW location for the particular class of interruption. The CPU fetches a new PSW from a second assigned storage location, and this new PSW determines the next program to be executed. When it has finished processing the interruption, the interrupting program may reload the old PSW, making it again the current PSW so that the interrupted program can continue. Now there are 6 classes of interruption: external, I/O, machine check, program restart, and supervisor call. Each class has a distinct pair of old PSW and new PSW locations permanently assigned in real storage. Okay, so the next section is about the general registers. Not going to read that. You have floating point registers, control registers. I'll read vector facility though. It says depending on the model, a vector facility may be provided as an extension of the CPU. When the vector facility is provided on a CPU, man, that's redundant. I wish they wrote that better. Anyways, it functions as an integral part of that CPU. The functions of the vector facility and its registers are described in the publication. Okay, so it has its own separate publication to this. Okay, so next section is I/O. Well, they're going to show us the register stuff. R field, register number, 232 bits and a 64. Channel sets is kind of interesting. They say the group of channels which connects to a particular CPU is called a channel set. When a channel set switching is installed in a multiprocessing configuration, the program can control which CPU is connected to a particular channel set. Okay, pause and read if you wanted to finish that. A channel relieves the CPU of the burden of communicating directly with I/O devices and permits data processing to proceed concurrently with I/O operations. Channel is connected with main storage, with control units, and unless it is a member of a disconnected channel set, with a CPU. And then down here, there are 3 types of channels: byte multiplexer, block multiplexer, and selector channels. Up here we have I/O devices and control units. Then operator facilities provide the functions necessary for operator control of the machine. Associated with the operator facilities may be an operator console device, which may also be used as an I/O device for communications or for communicating with the program. Okay, and that takes us to chapter 3. Thank you for watching.